Welcome to GRE Snacks, snackable episodes about the GRE exam and graduate school admissions. I'm Tyler, founder of Achievable, and we have an affordable GRE course that includes everything you need to ace your GRE exam. A full textbook, videos on key topics, tons of GRE questions backed by our memory-enhancing algorithm, a built-in study planner and essay grader, and full-length practice exams. You can try it out for free by visiting achievable.me, and if you like it, the code podcast will get you 10% off at checkout. Now, let's get started. Today, we have Priya Bhatia back on the show with us, and really excited to have you back, Priya. I'd love if you could just introduce yourself for those who haven't heard you before.
Yeah, thanks, Tyler. So I'm Priya Bhatia. I'm a GRE and GMAT tutor and instructor with 17 years of experience. I have 99th percentile GRE and GMAT scores, and I work with the MBA Exchange. We provide MBA admissions consulting.
Fantastic. Yeah, and so today, as part of our, you know, part of our GRE series, wanted to walk through a tricky GRE Quant word problem. And I love doing these because I think that, it's important not just to kind of talk about big picture stuff all the time, but actually to get into the nitty-gritty of the test and make sure that we're helping people prepare. And so I wanted to just maybe have you introduce the problem and then maybe we can kind of talk through it. Also, if you want to follow along with a visual aid, I'm going to post this problem to the link bit.ly slash GRE snacks underscore Priya2. That's also in the description in the comments, and GRE, the S in snacks and the P in Priya are all capitalized. Bitly links are case sensitive. So bit.ly slash GRE snacks underscore Priya2 is where you will find this problem if you want to follow along. Otherwise, we'll do our best to just describe it over audio here.
Great. Okay, should I go ahead and jump in?
Yeah, I think first let's maybe if you want to give a little context, what type of problem you would call this, and then we could read if you could read the problem, that'd be great.
Sure. So, first off, if you look at this problem, it's pretty wordy and pretty long. Just the problem itself is like a whole paragraph. And then if you just scan and look at those answer choices, right away you see that it's a bunch of letters. It's just all variables. So we would call this a variables in the answer choice problem. And
Mhm.
clearly it's challenging when you look at it because first of all, in quant problems, oftentimes the more variables there are, the more abstract the problems tend to be and the harder they tend to be for students to wrap their minds around. Um,
Right.
if you see a problem that is really the same, has the same content, the same question, but it has numbers, it tends to just be much, much easier for students. So I picked this problem because this is the type of problem that a large percentage of students would look at and would just kind of scratch their head and say, I have no idea where to even start. So let's go ahead and dive in. I'm going to read the question. So it's a certain car company manufactured X cars at a cost of C dollars per car. If a certain number of cars were sold below cost at a sale price of S dollars per car, while the rest of the cars were sold for the normal retail price of N dollars per car, how many cars could the company afford to sell at the sale price in order to break even? No profit and no loss.
hmm And so the goal of this, it sounds like, is to essentially find the equation that equals zero almost. But it's all variables, so it's kind of hard to imagine this, right?
Exactly. Yes, exactly. And if you look at it, we have one, two, three, four different variables in this problem. That's kind of usually on the upper limit of the number of variables you would see in a problem. Usually you won't see that many variables. I'm not sure I've ever seen a problem with more than four variables. So this is kind of at the max in terms of how abstract it is and how many different moving parts and pieces there are. But like you said, you are going to set an equation equal to zero, and I'll get to that in just a moment, but I want to back up for a second and just talk about how to tackle a question like this when you're learning. And I want to first of all specify that what we're going to walk through today is a learning approach. It's not necessarily an approach for if you saw this question on the GRE, how would you solve it under time pressure on the test? Because the approach that we're going to do is really too time consuming to execute while you're taking the exam, but it's really meant as a learning tool to help you kind of break a problem like this down, wrap your head around the different parts and pieces, and learn how to put everything together. So just want to kind of specify that up front, that this is the kind of strategy that you want to be doing in your study time when you see challenging word problems like this to help you learn. Eventually, basically, after you've gone through this exercise that we're going to go through today and you see how to break such a problem down, then you're going to practice more of these types of problems on your own. And eventually, you'll get to a place where you could comfortably do this problem on the GRE exam itself. But today, we're kind of starting at square one, just sort of teaching you like how do you take a super complex word problem and how do you break it down. So,
Great.
as I mentioned, you could see this exact same problem with numbers, and it would just be so much less intimidating and so much more approachable. And so, the very first thing I suggest when you see something like this with so many letters and unknowns is go ahead and just substitute some very simple numbers in place of the letters. So,
Right.
I've just picked some nice round numbers, and where it says simple parallel example, I'm basically rewriting the problem, but now I'm just putting real numbers. Real numbers make everything so much more concrete and easy to work with. So I'm going to go ahead and read the question now with real numbers. A certain car company manufactured 100 cars at a cost of $10 per car. If a certain number of cars were sold below cost at a sale price of $20 per car, while the rest of the cars were sold for the normal retail price of $30 per car, how many cars could the company afford to sell at the sale price in order to break even, no profit and no loss?
Mm-hmm.
So right away, it's something more approachable. We can start to actually break it down. So back to what you were saying, Tyler, you were saying that we're going to basically have an equation that we set equal to 0. Where does your mind go in terms of kind of where you get started with something like this?
Yeah, I mean, I think basically you want, revenue to equal cost, right? So on the one side of the equation, you have the number of cars and the cost per car. So that's X and C or 100 times 10. And then on the other side of the equation, you have how much money that they made, which was, some variable multiplied by s, right? And s in this case, we're saying 20. And then some variable multiplied by n, and n in this case is 30. So I feel like you, on the one side, you probably want to set up like basically xc is the cost. And then on the other side, you want to have, call it ys and zn, right? You want to kind of have those extra variables you're adding in, y and z, are how many cars for each of them. Is that a reasonable way to approach it?
Absolutely. Absolutely. Yeah. And I would say that what you just did demonstrates a pretty high level of understanding of this problem. But a lot of folks, I'll even say, backing up a bit more, a lot of folks kind of are even struggling to even get to that point. I think the process you just laid out was exactly the right approach, and had you definitely have a very good grasp of how to use variables. But we're going to kind of back up even a step from there and just kind of go really, really simple one at a time to construct that exact equation that you gave. And one part that you mentioned in there was that you created two variables of your own. And
Mhm.
that's a step again that I see a lot of students struggle with when they see something like this. when to create variables, how to create variables, and how to incorporate that with the variables you already have tends to just really leave a lot of people confused. So back to the very, very beginning of this is if we want to break even, no profit and no loss, in the most simple terms, what does that mean? That just means that the money we earn equals the money that's spent. And I write it out that way because even revenue equaling cost to some people can seem a little bit abstract. Like, what does it mean by revenue and what does it mean by cost? It just means money earned and money spent. So we now want to break each of those individual sections down. And we want to just start off by looking at the cost. So we're going to be producing 100 cars at a cost of $10 per car. So if I ask someone, hey, how much is it going to cost to produce those 100 cars? I think it's pretty easy to see that it's just 100 times 10. And those concrete numbers make things really nice and tangible for us. So 100 times 10 equals 1,000. But here, what I'm going to do in tandem as we do this problem using the numbers I created is I'm going to also write an expression in terms of the variables that they gave us so that we can see how we're actually constructing the equation. So we were told that the number of cars was X, and we were told that the cost per car was C. And so because we did 100 times 10, in terms of letters, that's X times C. So we have X times C is our cost. Okay, nice and straightforward. Then we have the money earned. So this is where it starts to get a little bit more tricky. It says that a certain number of cars were sold at $20 and the rest of the cars were sold at $30. And then it's saying how many cars could the company sell at the sale price. Notice here that they didn't give us anything to represent the number of cars at each price point. So you've got to just kind of take a step back and think about this. So you've got some cars being sold at 20, some cars being sold at 30, and then the constraint is that altogether there's 100 cars, but some of them are at $20.
Okay. So I made a small mistake there then, because there's no need for variable z, right? Like, and in fact, it's a mistake to include it because really, like, the total number of cars, which is x, and then that, y, that variable we did create, is the number of cars on sale. So then the number of cars that were not on sale is x minus y.
Exactly. And I'm gonna go through a little bit of a process again with some concrete numbers, because even what you said is for some reason it's just hard for people to express that algebraically. Like if I say that we sold Y cars at $20 per car, then the number of cars sold at 30 would automatically be 100 minus Y. But even that, just writing that out in algebra somehow is tricky for people to think of. And so I'm going to kind of even go a step further and just give some real numbers. Like if I sell 50 cars at $20, then how many are sold at 30? Well, it's 50 because 50 plus 50 is 100. But if I were to sell 75 cars at $20 per car, then that leaves over 25 at $30 per car. So you can see that basically what you're doing is to get the number of cars at the other price point, you're just doing 100 minus that. So breaking down the revenue, we have the amount from the sale cars, and then we have the amount from the regular price cars. And here I'm just going to create a variable, y. And anytime, sometimes people wonder, when do you create variables? Well, anytime you have something in the problem that's an unknown, that you are potentially solving for, but that's not been expressed as a variable, that's a good sign to you that you need to create a variable yourself. So we're going to just say Y. Let's say Y cars are on sale. And so Y times 20 would be our revenue from that. And then constructing the equation as we go, we would write that as Y times S. And then on the side for the regular price cars, like we said, the number of regular price cars is then 100 minus Y times 30. And I want to actually just mention, it would be okay for you to have created two variables like you did. You could have done Y cars on sale and Z regular price cars, but then you'd need to write one more equation to throw into the mix. What would that equation be? Do you know, Tyler?
Right, it would be, y plus z equals x or 100. But yeah, y plus z equals x.
Yeah, you'd be putting in Y plus Z equals X, and then you'd have to basically express, because you're looking for Y ultimately. Like if we go back to the problem is asking for the number of cars sold at the sale price, which is what we said is Y. Then, because you have that other letter Z, you then need to take the equation of the sum of the two, do the subtraction, and substitute it back. But that's why it's easier if you just go ahead from the jump and you just express the regular price cars as 100 minus Y. Just makes things easier. It's not wrong to do it the other way. And sometimes when you're writing equations, you won't always know the most efficient way, and you might kind of start out and write a second variable, but then along the way you may kind of realize, oh, wait, it's all in terms of Y. So why don't I just go ahead and express everything in terms of Y? So then back to the revenue equation, for the regular price cars, so with the numbers, we said 100 minus Y times 30, and then backtracking with the letters that they gave us, X minus Y times N. Okay, so we've now created all of the individual pieces we need for the equation. And now we can put everything together using that master equation, which is revenue equals cost. So we would just put everything together. And here again, we encounter a step that tends to confuse a lot of people. So I'm going to write the two equations. One, I'm writing it with numbers, and two, I'm writing it with letters. And then we're going to use the number equation to kind of inform and guide us on what to do with the equation with letters. So with the numbers, we said the cost was 1,000, and then we said the revenue was 20Y plus 30 parentheses 100 minus Y. And in letters, we have XC equals YS plus parentheses X minus Y times N. So even just looking at that equation with the letters, we know we want to solve for Y, but people may get stuck in terms of how do you actually solve for Y, because you have Y inside parentheses in one term and you have Y outside parentheses in another term. And so what we can do is we can look back at the number equation and we can use that to sort of inform what would we do. And this is kind of the really beautiful fact that you can get when you do a simple parallel example. Is it's like test driving the problem and like kind of figuring out step by step what you do with real numbers and then just taking that and applying it to letters. So if you had that top equation in terms of numbers and you were wanting to solve for Y, what would you be doing?
Well, you want to basically multiply out the what's in the parentheses. That's like the first step.
Uh-huh.
So then x minus y times n becomes, xn minus yn.
Yeah. Yeah, basically when you have numbers, it's much more obvious that you're going to do a distribution and you're going to get two terms that are in terms of Y, and then you're going to consolidate those terms together. It's kind of pretty easy to see that with numbers, harder to see that with letters. But now that we know what we're doing, we can go ahead and do that with the letters, is we can distribute that n. And as you can see, I've bolded the y's because that's what we're trying to solve for. So we distribute the n, and we now get this equation. xc equals ys plus xn minus yn. Now, even that can be a bit daunting. Again, when you see ys minus yn, you might think to yourself, well, what do you do with that? But again, inserting some real numbers. If you saw 3y minus 2y, it's pretty easy. What you would do is you would do parentheses 3 minus 2 times y. You would pull out the common term of y and create a parenthetical expression right there. And so now you can see xc equals y. We pulled out the common y. In parentheses, we have s minus n, and then we have plus xn. Okay? So what we're doing here is, again, we're just taking something that seems so abstract and we're just making it concrete by following along with the real numbers case. And I encourage you to do this anytime, anytime you're stuck in a problem like this with lots of variables and you're unsure of what you would do. You can always substitute simple numbers and just test drive it and see, because when you have those real numbers, it just becomes much more clear. Okay, so now we have something that's getting us somewhere. We have y by itself. Well, actually, I wouldn't say y by itself, but we have just one y in our equation, which is good. And so our goal now would be to isolate y. So we can subtract the xn from both sides. So we have xc minus xn equals y parentheses s minus n. And then looking at those answer choices, if you glance at the answer choices, you see that you have parentheses in most of the answers. 4 out of 5 of the answers have parentheses in both the numerator and the denominator. And so that's assigned to us. See how we have xc minus xn on the left-hand side? That's assigned to us that it might make sense to pull out that common x and create a parenthetical expression. So we can pull out that x, and we have parentheses c minus n equals y parentheses s minus n. Okay, so we're now almost to the finish line. What's our last step that we need to do?
Yeah, well, you just want to isolate y, so you just divide both sides by s minus n.
Yep, perfect. And then you have x parentheses c minus n over s minus n. And that is answer choice A. So this is how you can use a simple parallel example to help you unpack and understand how to work with a complex word problem like this. I want to make a quick note that during the test itself, during the actual GRE, when you're solving a word problem like this, there is a strategy for variables in the answer choice that you would actually be able to do during the test itself. And that is, if you saw a problem, typically with fewer than 4 variables, 4 is a whole lot, what you could do is you could actually create numbers, you could actually do all the math with the numbers, and then you could plug your numbers into all 5 answer choices and see which answer choice gives you the value that you solve for. I'm actually distinguishing a little bit between that approach, though, and what we did today. For a problem like this that has 4 given variables plus another variable that you yourself are creating, a problem like this would be likely just too time consuming to do out that way and then to plug into all 5 answer choices. So what I actually would suggest would be using this approach that we went through to help you workshop how to create the expressions and putting them all together, and then getting yourself to a place where you're comfortable enough with the algebra to just do it algebraically, because it would become a little bit too time intensive to plug in 5 different numbers and try to plug that into 5 different answer choices to see which answer choice is the right one. So
Right.
today what we did is more of a learning tool than an on the test strategy.
Yeah. Yeah, that makes a lot of sense. And I mean, for me at least, the crux of the problem or the things that really made this like into a solvable variable equation were figuring out that number one, your goal is for revenue to equal cost, right? That is, and then making the equations with the variables for each side of that. I think without that, you basically can't do the problem, right? And I think that it is, it's important to understand what the problem is asking for in the context of the variables. And then the second thing was then, putting together that initial equation where we said, okay, on one side we have cost, which is X times C. On the other side, we have the revenue from cars on sale, which is Y, the new variable we created, and S. And then plus, the amount from the regular priced cars, which is X minus Y. So, 100 cars minus whatever were on sale, multiplied by the third price N, the normal retail price. I think like just like those two steps are crucial for this. And then after that, I think like, I mean, I don't know, this is just me, but I feel like then it becomes something that if you're saying, okay, now I solve for Y, it becomes pretty easy to kind of go from there.
Mm-hmm. Yeah. And then there is that one confusing step though, I would say, even when you have your equation, xc equals ys plus parentheses x minus yn. I think even that step is a little confusing as to what to do since you're trying to solve for y. But again, always just revert back to looking at what you do with numbers and then extrapolate that and apply it back to the problem with letters.
Great. Thank you so much. This has been GRE Snacks, hosted by Tyler from Achievable with Priya Bhatia from the MBA Exchange. And Achievable has a great online GRE course that you can try for free at achievable.me. And be sure to use the code podcast to get 10% off if you like it.